Let's take a look at problem 5 from chapter 5, section 1, where we have two cars accelerating along a straight road. So two cars are traveling in the same direction along a straight road. We can see that car A starts off at time t equals 0 and over 2 hours accelerates to 96 kilometers per hour and then starts to decelerate over the next 2 hours back down to 0. Car B starts 1 hour later, so here's where car B starts, and it accelerates up to 48 kilometers per hour in 1 hour and then decelerates down to 0 over the hour from 2 to 3. So here's car B starting later and finishing an hour sooner, but only accelerating to 48 kilometers per hour, where car A accelerated to 96 kilometers per hour. All right. So it looks like car A is traveling for the entire 4 hours, and car B is only traveling for 2 hours. So from 1 to 3, car B only drives for 2 hours because it started off 1 hour after car A and finished 1 hour before car A. Car A goes the entire 4 hours. So based on the marks, I would estimate that car A's maximum velocity is 96 because it looks like it goes up to that second mark. And there's going to be some question. I haven't scrolled down yet. I only know the form of the question. But I'm going to predict that we need to find the area under this car B's velocity graph and also the area under car A's velocity graph, because that's going to tell us how far each car went. Approximately how far did each car travel? So the area under each curve will be the distance. The area under the velocity graph is the distance traveled. So the area of car A, and we have secret math knowledge for this problem that we didn't have when the book wrote this problem. So we can write distance that car A traveled as the interval from 0 to 4, because that's when it was driving, of the graph v of t dt. And that's just going to be the area of that triangle. So it's going to be 1/2 the base of 4 hours times the height of 96 kilometers per hour. So it's going to be 2 96s or 192. And all we're doing is the area of a triangle. And then the distance of car B. Once again, let's use our fancy notation. Oh, we're not starting off at 0. What's B going to integrate? It's still going to be a base times a height, and the height is 48 kilometers per hour. How long was car B driving?
2 hours.
2 hours. So the base of the triangle is going to be 2 hours. And what hours, what 2 hours are we going to integrate for car B? Since it started driving at 1, we'll integrate the 2 hours from 1 to 3. So we don't integrate from 0 to 2 because from 0 to 1, car B was not going yet. To find the distance that car B traveled, we're integrating from 1 to 3. And so that'll be 48. Any questions? In both cases, the velocity was positive, so the distance will be increasing. The cars are going one direction. The area, the derivative tells you what direction the function is going. the area tells you how much it goes. Any questions? Great. So we're just doing area of a triangle for each of these triangles. All right, let's pause the video here because we're out of time. And that was 1, 2, 3, 4, 5 videos today. A new record.